Hello everyone, welcome to Sir's classes. This is Tushar Shaw, and in this video we'll be discussing or reviewing the book Principles of Chemical Nomenclature by J.G. Leigh and Metanomsky. Okay, basically these names are like quite difficult to pronounce. We call it as the Leigh's book of chemical nomenclature. Okay, so basically this book is mainly about the organic nomenclature, and some part of inorganic nomenclature is there for the complex compounds, for the coordination compounds as such. But so we'll be discussing them in a proper way. So first of all, why this book? You may just know that in any competitive exam, competitive or non-competitive exams are happening across India or in foreign. So all those kinds of exams don't have the IUPAC nomenclature. Basically, they don't have any IUPAC nomenclature specifically in their syllabus. Okay. So the point of reading this book would be like reading this would be pointless. But the thing is that why I give focus on this nomenclature, because many times in these exams only, you, for example, let us say you are given a certain reaction with the name of the compound being given to you. Okay, and many times I've seen students that they know the reaction, they know how to proceed with the mechanism, but they can't figure out the exact structure from the name that is given to them, be it a common name or an IUPAC name. Okay, so that is why the nomenclature is very important, though it is not given any focus in our undergraduate or postgraduate level or in any competitive exams. This part is basically taught in usually your class 11 12 level in your higher secondary, and after that there is no such focus is given in there for this part. So the total thing that you will be learning in your about nomenclature is in your higher secondary level. Okay, but obviously when you are moving ahead with chemistry or taking it as your in your undergraduate and your master's level, things might get very tricky. Okay, and for these tricky these huge compounds, tricky some substances, we require like a detailed form of nomenclature. Obviously we can study our earlier notes and those 11 12 stuffs, but that won't be like sufficient enough. So I recommend this book for you, the principle of chemical nomenclature. I may, if you like, I am giving my mail over here, Tushar. Let me just use another pen. uh, So my email ID is Tushar Shaw 9420 @gmail.com. Okay, so if you require this book, obviously now this is an extremely like rare book which is not available obviously in India or in any like markets or stuff. Like if you have any book market available near your area, and you may go check that bookstore out, you won't be finding any like this book in there, because first of all this is a foreign author book with a foreign publisher. Okay, so it is has a very rare chances of being available in India from the direct store market. You can obviously order this book on Flipkart or Amazon, and the PDF of this book is easily available on the internet. So if you find it, it is okay, and if you don't find it, you can mail me in this Gmail account. So I'll be just sending the PDF back to you. Okay, so this was all about the importance about this book. So let us see what are the salient features of this book and how can we use them to like use these books for completing all the nomenclature part, and how can we use it for understanding how nomenclature exactly works, and how can we use it in certain chemical reactions and identifying compounds. Okay, so first of all you can see that obviously yeah. So as I have told you, three authors of the book are there. We identify the book as it is named. Let me use one another ink. Okay, so we identify it with these three book writers. Obviously, we name it as in normal languages. We say it as Leigh's book of or chemical nomenclature, or basically not chemical. We the main focus over here is organic nomenclature. So we will be going into that only. The inorganic nomenclature for the complex compounds, those are given in properly in any standard textbook. So we'll be when we'll be discussing that, I'll be showing them to you. Okay, so this book is basically our concern for this book is the nomenclature related to organic species. Okay, so uh, let us look at the contents over here. So the introduction and definitions. Definitions is quite required for you, because like when we are studying nomenclature in details, in detailed way from the beginning, definitions will need to be covered, and I'll be like explaining them to you. Okay, so first of all, how can the formula of any organic compound? Basically, now you must consider that except for this chapter and this chapter, all of these are like considered using like considered for organic molecules only, with some like attachment of inorganic molecules. But the organometallic compounds and basically here you can see the coordination nomenclature, these are basically the inorganic part. And polymer nomenclature, okay, this is also one of the important things. And biochemical nomenclature, which is also a part of organic one. Okay, you have the naming of carbohydrates and amino acids in your syllabus. You have DNA, RNA nomenclature. Just basically you have structures, but you need to know the name. Okay, so these also come under the organic part. So we'll be like looking into them one by one. So for the basic organic chemistry structures, we have we can see the empirical formula. Then we have to deduce the molecular formula, structural formula, and the sequence. Like if you are given a chain of which one will be 1 2 3, those kinds of species, you have to like you will be studying in these. Okay, then we have formula of groups. Okay, we have groups like cyanide, halides, sulfonic acid, carboxylic acid. These are few examples of the like hundreds of groups that are available, like, that are used in organic chemistry. So, in nomenclature regarding these groups also will be is quite properly explained. Then we have this three-dimensional structure or projection, basically stereochemistry. Okay. So why stereochemistry is involved in nomenclature? Because you can see that like many a time examples are given. Let us say the example like let's say malic and fumaric acid. Okay. So basically. Uh, okay. So this one is named as malic acid, and this one as fumaric acid. Okay, let me delete these. So basically you can see that this one is the cis isomer, and this one is the trans isomer. Okay, both of them have the same chemical connectivity, both of them have the same like molecular formula, but they are oriented differently in space, in 3D. Okay, and that is where stereochemistry comes. Because of this orientation, these molecules might be reacting differently. Okay, and that is why stereochemistry is involved in nomenclature also, because you can see that the molecular formula is the same for both the species, but the only difference is caused because of the orientation, and therefore we need to define the orientation while writing the IUPAC nomenclature, so as to determine which of the compound is being talked about. Okay, because though malic acid and fumaric acid, as I have already telling you, though malic acid and fumaric acid have the same structural formula, they are not same compounds. Okay, and this is thus because of the fact that they have different chemical different stereochemical environments and different orientation in space. Okay, then we have the nomenclature related to isomers and stereoisomers, so that would be one. Then the nomenclature of inorganic, basically, which is firstly binary type nomenclature, where when two species, for example, let us say NaCl, we have sodium we'll be considering, chloride will be not chlorine, we'll be writing chloride. Okay, so those kinds of. Then we have complex nomenclatures, like for example more salt you may take. Okay, potassium aluminium sulfate, that is one example. Okay, more salt. These kinds of examples will be explained in complex nomenclature systems. Then we have this coordination nomenclature, which is like most important nomenclature part in inorganic chemistry part. So that would be like, that is like, you can see that 20 pages are taken for explanation of this part only, so it is like quite properly explained. Okay, then we have the substituted nomenclature, we'll be seeing into that, and the functional class nomenclature. These are like quite not quite important, because like those are just the recommend like the substituents and the continuation of the coordination nomenclature part. So we'll be going with that. Okay. Then we have the nomenclature of the main group element, that is the nomenclature of compounds involving iron, the D block elements. Okay, iron, you may say chromium, those kind of species. Okay, and then we have the organometallic derivatives. Okay, so basically the organometallic part is also a continuation of the coordination chemistry, but it has a separate chapter. It because many examples are there in organometallic part, so you can so we have to consider that accordingly. Okay. Then we have the polymer nomenclature, which is basically like also one of the important part if you are mastering in, like if you are planning to move ahead in polymer chemistry. Okay, like for normal chemist, for pure chemist, polymer chapter is not like so much important, and basically it is not given so much focus about. Okay, and if you are a student of polymer chemistry, if you are doing your masters in it, if you are doing your PhD in that, then it is like quite natural that you will be requiring nomenclatures of how to give names to certain polymers and various species about that. Okay, so for that case we have the nomenclature based on different types of structures and those kinds of stuff. And the main thing that polymer that we need to study in polymer chemistry, that is trade names, which is extremely important if you are a polymer chemistry student, or you are trying to like master in or polymer chemistry. Why? Because we know that let us say for example nylon 6. Okay, nylon 6 is formed from caprolactam after the Beckmann rearrangement. We all know that. Okay, we all know the mechanism of how it is formed. But nylon 6 is a trade name. Okay, nylon 6 is not the name of the not the IUPAC name of the whole complex which is formed, whole polymer which is formed. Okay, nylon 6 is a trade name. And what is a trade name? Basically a trade name is something that we need, that these polymers are the main use of polymers is basically they are used in huge amount in the industry. Okay, in the industrial sector, more than the academic sector or the educational sector. Okay, like for organometallic compounds, you can see that the application of polymer chemistry in industry is way more than that of organometallic chemistry. Okay, so for that case there is a separate topic or a separate form of discussion in accordance to the trade names of polymers, because they need to be recognized in the trade name so as to use effectively it in the polymer industry. Okay, not everyone in the polymer industry like, is industrial parts are chemically educated, right? Like they might not have a chemistry background, but they need to like if they are working in a polymer industry in any factories or any companies or such, they require to know these names. Okay, so that is why the trade names have been come. Okay, moving on to the last part of this book, that is the biochemical nomenclature. Basically this is my favorite part. Okay, my favorite part of like organic chemistry and both organic nomenclature, because carbohydrate nomenclature is one of the best things. Like it is like a game. Basically it is like a game. Okay, so the different types of carbohydrates would be having different names, and those different Harvard projection formulas and different kind of production projection formulas would be adding up to the nomenclature as well. Okay, so those kinds of stuff we will be discussing. Okay, then we have the nomenclature and symbolism for amino acids and peptides. Okay, so amino acid nomenclature is like kind of easy, but I would prefer, like not prefer, obviously we have to study each and every one of them, but carbohydrate nomenclature is my favorite over here. Okay, then we have the lipid and steroid nomenclature, which are not so much important. You can see that only one page is taken for that. So we will be like given us a small detail about that. Okay, and the last chapter is nomenclature in the making, that in recent journal papers or in the recent publications, what are the newest nomenclature that haven't been there published in any book, or haven't been like so much widely approved by IUPAC. So therefore those are in the making. Obviously we might be seeing them in few years to be involved in this in regular textbooks about nomenclature, including this one. Okay, so this was all about the contents and the basic material that is present in this book. I would highly recommend this book for if you are studying any sort of chemistry. If you want to appear in any competitive or non-competitive exams, I would specifically recommend you this book. Though it is not there in your syllabus or not following any curriculum, still it is important and it will be required if, like it will be proven fruitful if you are like if you completed the book as well. Okay, this book is not so huge. You can, as you can see, that this book is just of 127 pages. Okay, that involves the index too. Okay, so 100-page book is not a not a quite a big of a deal if you study, if you like sit with your copy and your pencil. I guess you be like, if you have a certain amount of knowledge regarding nomenclature already, you might be completing this book in a week. Okay, it is not that of a big deal, but I would recommend this book for your like for structuring and sharpening your knowledge about IUPAC nomenclature. Okay, so let us look at the details of this book. I'm obviously not, I'll be explain not I won't be explaining the preface over here, but that's fine. So the introduction is given by the chemist. You may just stop the video. You may read about it, or you may. I've already given you my email in the earlier in this video. So if you want, I'll be sending it to you. So if you may, like email me and give me the ask me about it. So I'll be sending it to you. Okay. So first of all, definitions are being asked about. Okay, so you can see that we have the chemical formulas of certain compounds. How can we write the? You can see that where we have to write the mass number, the atomic number. Basically, this part of nomenclature is used in radioactivity. Other than that, there is no such like requirement of like mentioning the mass number and the atomic number of the same atom in the same part. Okay, other than radioactivity is not required. Okay, so now I don't think I need to explain all of these, because these are the chemical formulas, or the yes, the symbols of each atom present in the periodic table. And obviously there are 118 of them, and each of them you have been studying since like from your class 5 6 when chemistry started to come up. You have been learning this since quite a lot of time now. Yes, people still have problem memorizing the periodic table, though it is required for like solving given amount of questions. But like you may have many people have the different way of memorizing the periodic table. I'll explain my way to you, and then it will be easy for you. Okay, so I would don't think I will be explaining this, so you can use this. So the periodic table, you can see, you can rotate your phone and look into it. The periodic table is not such a like extreme thing that you can't find on the internet. You may get it on anywhere, and many people have this already memorized. Okay, including me, obviously. In the next video, I guess I'll be explaining it to you how to memorize the periodic table in a fast way. Okay, this would be the topic of my next video. Okay, so formula. So first of all, what is empirical formula? It is like properly explained. You already know, because empirical formula is a concept that was already like started to explain in lower classes, that is in class 9 10. Okay, then we have this molecular formula, the structural formula. Okay, and basically we have now come to the organic species. So we have this. You can see that this is propane. Propane can be written in the open form, the condensed form, or the chain form. Okay, these are the three forms that we can write about. Okay, then we have this the periodic table, the sequence, element sequence. These are given properly. Okay, then we have the some very important functional groups. Okay, so functional groups that are given, you can memorize these. Obviously, it is quite properly given. Then we have the examples related to alcohol, how they are used, and then the three-dimensional structural formulas. Okay, how they can be used, and then the types of lattices that are available, and the types of orientation that a molecule can adapt in 3D space. Okay, so all of these are like quite famous examples, but not all molecules acquire this type of all of these the structures. These are like 14 Bravia lattices, and those are like used in both organic inorganic conventions for nomenclature and stereochemistry. Okay, so yeah, so this was one thing, the one perspective. Then we have the exact stereochemistry, that is the three-dimensional formula, Fisher projection, Sawhorse projection, Eclipse Newman projection. Okay, and then in accordance to that, we have the explanation for the coordination species in how 3D in how they are arranged in 3D orientations. Okay, And then we have different projection formulas, the board conformer, the chair conformer of the cyclohexane ring. Okay. So naming of substances, we have types of nomenclature. We all these different definitions are given. Okay. Then we have this, as I told you, more salt and ammonium sodium hydrogen phosphate. Then we have aluminium potassium bisulfate. Okay, complex examples are given. So here is one table for the name of ions and groups. Okay, many tables are there. I'm not stopping here. Obviously, I'm scrolling it down. If you don't have the book and you want to have a look at it, so you may just pause the video and sit there. Okay, so yeah, this is like many groups are given. Obviously, many pages are there. Okay, so it is over now. Anyways, so groups, many examples of certain groups are also given. All these groups I'm not stopping here because these things I wouldn't like to explain because these are like quite extensive and quite extensively used in a normal chemistry, and I don't think like for example methanolate CH3O minus. Normally you know this at methanolate or methoxide. Why would I need to like give an emphasis on that? Because you may just have a reading about it and then you'll be cool. Okay, as I told you, this book is not something new and not something new that which you are learning of. Okay, this book is just for sharpening your knowledge about nomenclature so that you can perform well in your competitive exams and non-competitive exams. Obviously, considering the fact that this part might not be there in your syllabus, and still you are going into details about that so that you can solve questions properly. Okay, this is the only thing this book is concerned about. Okay, so you can see the subsequent groups having the radical name. These names are basically used in the organometric and coordination parts. Okay, so the hybridization, the coordination number, all of them for complex compounds are given to you. Okay, here we can see organometric parts. Okay, then we have the ligand names and their abbreviations and their prefix and suffixes which we'll be using while naming the organometric and coordination nomenclature. Okay, so you might be requiring this book for solving these questions. Okay, nah, not solving, for reading this book out. Okay, so you can see that how cis and trans isomer differentiate. Obviously they are different compounds, so you require different nomenclature for them. Okay, then we have polynuclear complexes. Examples for that are given. Okay, now we come into the basic nomenclature about organic chemistry, how they are used. Okay, these part I guess you already know because you have studied these in your lower classes. So the basic part of the basic concepts of these part you already know. What you require to do is give it a reading and solve more examples related to that so that you can sharpen your grip in organic nomenclature. Okay, and many just examples like oxygen, azepine, triazine. These molecules we have not studied in our lower classes or any other classes as well. Okay, these are specifically taught in masters. If you take organic chemistry and bio drug chemistry or those kinds of heteronuclear chemistry as your project, as your elective, or any kind of stuff like that. Okay, other than that, it is not usually discussed in any university level. But these molecules come in competitive exams. Okay, so you require knowledge about that. Though these molecules would be reacting, as the chemistry is same, the reaction mechanism would be properly followed in accordance with the exact rules which are set up for reaction mechanism. The only thing is that is my concern is the nomenclature. If you are given triazine in your question paper, triazine reacting with some kind of species, maybe we are oxidizing triazine. Okay, I mean you might be knowing the how oxidation mechanism work and what would be the product, but you don't know what the triazine molecule is. You will be losing your mark then and there. Okay, so these molecules are given. I'm not stopping here. Many examples are given. You may just pause the video or slow the video down so as to like give a proper look at the exact examples that are given. Okay, uh, many examples are given. You can see. Then we have this organometallic compound part, which is basically the nomenclature involving organometallic species. Uh, you can see that the first of all the skeletal replacement and the transition metal. Basically, this part is not quite properly explained. So, so obviously, this book has a different part, that is the nomenclature of inorganic chemistry specifically. So I'll be reviewing that book also for inorganic purposes. But we are doing the organic series, so I'll be focusing into organic molecules now. Okay. Then we have this polymer nomenclature, which is basically the formation of like how we attach poly in certain chemical names, so as to define that certain chemical chemical compound is has formed a polymer. Okay, so like for example, we have ethylene. Okay, we have ethylene. So ethylene polymerizes to give polyethylene, and which is basically ethylene has a IUPAC name ethene. Okay, and it polymerizes to give polyethylene, and that is the polythene that we use, which we normally say as a plastic bag. We say it as polythene. Basically, it is polyethylene. Okay. So yeah, so examples of poly compound polymers are given. How the nomenclature takes place, that is also explained in this book. So I highly recommend, if you are a student of polymer chemistry, if you want to like have if you have polymer chemistry in your syllabus, this is the best book for you for nomenclature. I'm not talking about reactions, but this book will cover all of the parts of nomenclature which you can study anywhere in the anywhere in your university level. Okay. Then we had this biochemical nomenclature, which was my favorite, obviously. As you can see that this is basically like a game, as I told you already. How the carbohydrates are there, what are the types of carbohydrates, in accordance to that, what would be the nomenclature, the DL and L nomenclature, which is basically the stereochemistry one, but it is considered as IUPAC. Okay, you can see alpha D, beta D. These are all kinds of nomenclature which we normally use for the nomenclature of a carbohydrate, so it is required. You can see that the structure of glucose, galactoparanose, all these structures are given. Okay. Then we have the nomenclature for amino acids. We have the nomenclature for peptides. All these peptides, how they are attached to the one another, and how like we will be naming them. Okay. Examples like oxytocin, cyclic ester. Okay. Now, lipid nomenclature is not so important. Steroid nomenclature is also like a page or two. Okay. So these are like basically these are quite just an example that you need to study. Other than that, the lipid and steroid nomenclature is not so much required. Okay. So nomenclature in the making, I am just scrolling it down quite slowly, so you can just give it a read about that. And other than that, this book is like completed. Obviously, the index are there. So I would like to end this video here. I hope you have learned a lot about this book and how this book will be helping you in polishing and sharpening your knowledge in nomenclature, which obviously will be beneficial for you if you study it quite properly. Okay. So so let us end this video here. Thank you guys for this video. I'll see you guys in the next one.